Welcome everyone to the second day of Edge Impulse Imagine. We had a fantastic day yesterday. It was day 1 of 3, and it was amazing. We had our first event, our first ever event live from Mountain View. We had a lot of really interesting speakers and over 3,000 people watching online all over the world. And today we have another fantastic day. We're starting off with a massive, interesting panel, and we'll get into that in a second. But before we do that, I've actually got a surprise. So let me stop sharing that screen, and let me bring in our guest. Woohoo! Jan! Welcome!
Thanks, Alessandro. Yeah, man, so sad to not be there in person in Mountain View yesterday. But yeah, here we are on video. That's the second best thing.
Yeah, it was really sad not to see you on stage yesterday, but I'm really glad that you're here with me this morning, and we can unpack some of the cool announcements that we heard, on stage. There was some really interesting announcements. So let's go through some of the interesting things that we came across yesterday, and then we'll kind of cover a little bit of what's happening today and tomorrow before diving into the really interesting panel. So first of all, we've got about 40,000 ML projects being built on our platform, and 10,000 enterprises and tens of thousands of developers, building stuff every day. But let's talk about what makes all of this possible. So Jan, let's start with discussing the importance of our partner ecosystem.
Yeah, I mean, if you told me 2 years ago when Zach and I started the Gym Pulse that there'd be 40,000 projects on the platform right now, I would jump like a hole in the air. That's probably not an English saying, but and it's kind of amazing. And we can't do that by ourselves. We're 35 people now, and so I think the really cool part, and I think that the biggest catalyst for all of that is our partner ecosystem. It's the silicon vendors, it's the SIs, these are customers that are actually building stuff. It is kind of this breadth of our ecosystem. That is what makes us really unique. And I think yesterday was an amazing testament of that. We announced 3 new partnerships. For those of you who missed it, with Sentient. It's been truly amazing. That has been over a year in the making, over a year of development. Learned a lot about what it means to do always on wake word detection, and now kind of growing that to other parts. Today we have with Synaptics. Naturally, we've been working together with Ada Compute in the past, and Ada Compute and Synaptics are now kind of joining forces. DSP Group is being brought into that. So Synaptics is really positioning itself as the new kind of silicon vendor for specialized AI. So really awesome to also welcome them into the ecosystem. And then last, like not a silicon vendor per se, but super interesting as I meet silicon vendor in the industrial space with Advantech is really showing that what everyone who's watching the stream right now is doing is really applicable also to industrial use cases. And combine that with the amazing existing partners that we have and that we're going to hear from today at all the workshops. I just scrolled through on YouTube. It is absolutely fantastic, and like holy shit, and thanks a lot to everyone watching here.
Yeah, and so true. And with it's so great to be able to share all these kind of partnerships and all these things that are happening with our audience. But with great power comes great responsibility. So what have we learned from our partners that we can, that we've been kind of working on and improving and making better for everyone?
Well, so much. It's funny. So today I was making a presentation for a different conference, and I was going through this one folder with all the presentations, and I found the very first presentation that I gave about Edge Impulse to an external audience. And it's kind of funny, kind of this building blocks of, there's data flowing, then there's some processing block, there's some learning block, and then you deploy. That was there from the very beginning. But working with large customers with real data and working with partners that have real experience shipping this in very large volumes, we start learning that there's a lot more before there's data, and there's a lot more after you train the model. And that's where we see great strides. So all of the stuff around ML ops, how do you get data from multiple sources? How do you combine that? Like all the stuff that Aura talked about yesterday, she from Aura. like that is stuff that we've learned together with Aura and other customers over the last years. And yeah, being able to, like, we have built all that for enterprise customers now, that we're going to open up for the rest, for everyone in the developer community in Q1. Super cool. Really like proven tech. And then on the other side, like after your model is done, we also realized that if you have a model trained up, that doesn't tell the whole story. Like, what does 90% accuracy actually mean? So something really cool that we've learned from Sentient is that they always have kind of this post-processing steps after network. And that's where you kind of tune, like, okay, when should this activate? What type of filter should I apply over the results? What are kind of the considerations that I need to take in? And all of that we're currently integrating into our new model testing page. And so that was really, really awesome. Like, if you haven't seen the keynote from Dan, like, go watch that. It's truly groundbreaking stuff. And then underpinning all of that is the work that we've done with the silicon vendors in accurately profiling all of their targets and knowing what their targets are capable of and what the silicon is capable of. And because we now know, the possibilities of silicon and the strong points of silicon, we've been able to put together Eon Tuner and the new stuff that we've added to Eon Tuner. Right now, we've added images, so computer vision to the tuner, and we've added motion to the tuner. But the only way that is possible is because we know the exact profile of every silicon target, making that an incredibly powerful tool. So yeah, it's really cool. Like, we give kind of this narrow base of functionality, and our ecosystem providing the rest, which is so powerful to see.
Yeah, so cool. I mean, so many different things, and some of them are live, some of them are not. But if you haven't, as Jan said, if you haven't heard all the announcements, go back and you can watch the live stream from yesterday. It's all on YouTube. It's all available. You don't have to register anywhere. Just go on YouTube on our channel and watch it again. And with that, I think, Jan, I'm really excited about today, and I would like to kind of go through some of the things happening today. So let me just reshare my screen for a second. Here we go. So what's really cool is that today is all about real use cases, real industries building things with embedded ML, right? So we're kicking off the day with a cool panel that's going to be moderated by Sally Ward-Foxton, and it's going to have participants from GE Grid, Siemens, Flex, and Tata Steel Europe. So that's going to kick off the day. But then we're going to have the rest of the day all about real use cases built by partners. So we're going to have workshops that you can attend. Again, all available on YouTube. So you can go to our channel and find the right workshop that you're looking for. So we're going to have workshops from NVIDIA, Nordic, Texas Instruments, and we're even going to have one workshop supported and sponsored by Sony, actually in person in England. So we have Adam Taylor actually running the workshop in England, and it will be streamed live to everyone that wants to attend. And that's a Sony workshop with Adam Taylor. So you find all that content on our YouTube channel, but you can also find it on the Imagine website. So the easiest thing to do is actually to go to the Imagine website and add sessions to your calendar, because that will allow you to get the direct link for the right session that you want to attend on your calendar. But if you don't want to do that, again, go to the YouTube and you'll find all the sessions. Cool, so that's today. And then tomorrow, we have even more workshops, but the day will be kicked off by Massimo Banzi. We'll then have two panels, really interesting panels with some experts and real leaders in the space. And then we'll have a lot of community-driven workshops and community showcases of things that people have been building in the last year. So I'm really excited about today and tomorrow. And Jan, is there anything else that you want to add about the next 2 days?
No, I mean, it's been amazing so far, seeing the chat that people have, the excitement on stage, the photos of the after party yesterday in person, the amount of you that I couldn't join, and really, really looking forward to listening both to the panel and seeing everything that's going to happen today and tomorrow. Absolutely. I mean, it's been fantastic already, and it's just day one. So let's kickstart day two. And with that, I'm going to kind of introduce this amazing panel
getting ready for a smarter industrial future. The panel is going to be moderated by Sally Ward-Foxton from EE Times, and I'll kind of ask everyone from the panel to join this live stream, and I'll come off and I'll let kind of Sally do the introductions with everyone else. So if you guys can all join the live stream, that would be amazing. There we go. We got everyone on. Awesome. Sally, all you. I'm going to take myself out and leave you to the panel. Enjoy.
Thank you very much, Alessandro and Jan. Hello and welcome everyone to our panel discussion session at Imagine 2021 today. The topic today is getting ready for a smarter industrial future. I'll be your panel moderator today. I'm Sally Ward-Foxton with EE Times. I'm delighted also to introduce our expert panelists today, and they are, in no particular order, Michael Stahl, Principal Key Expert Engineer from Siemens. We have Mittal Kanobar, Chief Applications Architect from GE Grid Solutions. We have Juan Noguera, Senior Director at the Connectivity Center of Excellence at Flex, and Menno van der Winden, General Manager for Advanced Analytics at Tata Steel Europe. So the panel today is being streamed live on YouTube. So to the audience, if you are watching us live today, please enter your questions for our panel of industrial experts in the YouTube live chat box, and we will try to answer as many questions as we can today. Okay, let's get started. Let's start by talking a little bit about how you all are using embedded ML today. Maybe let's go first to Michael over at Siemens. Michael, tell us about how you're using embedded ML or how you're thinking of using embedded ML.
So the problem is that Siemens is very large, and I'm basically working for the Siemens Technology Department, which is basically consulting and doing research for all of our business units. And maybe there are some interesting examples. For instance, one of the examples for embedded ML is obstacle detection and handling in trains. So where you just want to figure out whether there is some obstacle in your train path in order to prevent accidents and these things. So this is one example. And this goes from trains to, for instance, industry automation, or another example would be energy analytics. For instance, what we are doing is we are adding sensors or IoT devices to existing factories in order to figure out what is the power consumptions, what are the carbon dioxide emissions, and help then the people to improve and optimize power consumption and reduce, obviously, carbon dioxide emissions. So these are only two examples, and basically just the last sentence here is that we are using embedded ML and AI in almost all business units, from medical modalities up to trains, whatever you can think about. So this is really an interesting time to be because of that fact.
Absolutely. Thank you very much, Michael. Mittal, let's come to you next. GE Grid Solutions. Mittal, tell us a little bit about what you're doing with embedded ML today.
Sure, Sally. So, as you mentioned, like I'm part of grids and energy, the segments. So, from our side, as a part of renewable energies and part of energy transition as overall vision, the focus on, applying this embedded ML technology to the devices that goes at the energy at the edge of the infrastructure of IoT. So energy efficiency is one of the kind of a thing that we're looking at. Driving the carbon footprints. How can we decarbonize? Bringing the renewable energy resources on board and optimizing the performance over there, and also the extending the life of equipment, uptime of in processes, industries, and really outside, like building a sustainable ecosystem. That's really that, and how can we go from the journey as a industry towards energy transition and build a future for tomorrow. So really excited to have this kind of technology as one of the tool, but it's a very effective tool, part of our business. Absolutely.
Sure, thank you. Let's go next over to Juan at Flex. Juan, maybe you could tell us a bit about how you're using embedded ML today and the reasons for that.
Yeah, sure. I mean, we are still very at the beginning of the journey, but for Flex there is mainly two reasons to use ML, and artificial intelligence. One is, of course, to serve our customers, because our customers, they are asking more and more for more smart devices, so that it's not enough to add sensors, but they want to get some more intelligence out of these sensors. And in many cases, in the past, this was collecting all the data and send the data to the cloud and apply algorithms there, and machine learning algorithms. But there are more interest in having this intelligence locally, whether it is because of privacy, like it happens in some medical customers. For example, we are trying to apply voice recognition algorithms for syringe auto injectors, because you don't want this voice to go to the cloud, come back, and so. Other applications like continuous glucose monitoring devices, where you can really learn a lot from the glucose level and from the patient, and try to correlate this with the way of living or other parameters that you can capture from the environment, from the patient is behaving, things like that. So one part is on the customer side, and the other one is for Flex internally. So we try to apply machine learning, trying to improve our manufacturing processes. Whether, as Michael mentioned, to try to save energy, learn how the energy is consumed, not only in the air conditions, but also, for example, try to understand in a clean room how you have to measure all the particles concentration. So, and you have very expensive sensor machines that they measure the particle, but sometimes it takes too long, until the particles are generated in one corner of the room to come there. So we are, for example, thinking in deploying low-cost particle sensors, which are not certified, but can give you some idea of where the particles are being generated, and create a map of or learning about how the particles in a clean room are generated to act in consequence and improve the operation time of this or react much earlier than you used to do it.
Fantastic, thank you, Juan. Let's go over to Menno at Tata Steel Europe. Menno, tell us about how you're using ML, or how is it affecting your industry or your business?
Well, ML as a whole is a very broad field, of course, and we're using that in many hundreds of use cases. But if we focus on the embedded ML here, then I think the situations where we want to use it, although we are starting up, is those where we have really high frequency data that are simply too big a volume to pump away and then to analyze in the cloud or even on an edge computing. So that is an area, and that's an area that we have a lot. Yeah, for us, MCSA is one of the key applications. The steel making process is rather complex. It has many steps, and they all involve electromotors, and they can all break down, or they can prepare to break down, if you like. So, as my colleague from GE was saying, preventing downtime, preventing quality issues where motors are not quite doing what they're supposed to be doing, and not on a few, but on a few hundred or maybe even a few thousand. That is where we see the biggest application.
Fantastic, thank you. Let's talk a little bit about the data. Like any ML application, embedded ML in the industrial field, data is absolutely crucial. Juan, let's go to you first this time. do you typically work on projects with an existing data pipeline, or is this something that you typically have to address?
No, usually we don't have this data pipeline ahead. So we focus in every new application, looking at what is the problem we want to solve, and then find out, okay, what is the data we need to capture, and then we pursue this data capturing, finding the proper sensors. But usually we don't collect data, or we have a pipeline of data which have been collected in the past. So we work on project basis, let's say.
Okay, thank you. Let's go now to Mittal. Mittal, what data types are you collecting typically? Time series data, vibration sensor, others kind of sensors, or is it more like images and video and audio? What kind of data are you using today?
Sure. I the typically using the time series data for currents and the electrical signals, and my colleague like Manon mentioned that kind of applications for that. It's typically the time series data integration at the edge level when it comes to the edge, but it's a very high volume, high sampling rate. The time series data that we typically apply to.
Thank you. Menno, I guess same question. What kind of data are you using? I imagine the answer is pretty similar with the time series data, but do you have cameras anywhere or anything?
Absolutely. We do have lots of cameras and other sensors, but for the embedded ML, I'm very much on the GE route, that it's the high frequency stuff. For the machine learning as a whole and more the edge applications, then cameras are used very suitable for that as well. So we build smart cameras out of stupid cameras, and that is or dumb cameras, if probably a better word. That is a huge application. It's also far from trivial. All these YouTube films, just like, okay, upload your stuff into Microsoft Vision, and then 10 minutes later, all your problems are gone. It's not that easy in practice, but still, it's a very promising field.
Sure. Michael, let's cross over to you at Siemens. You mentioned a range of industrial applications there. What kind of data are you working with? Images of train obstructions, or is it more like the others are saying, more on the time series data?
So we have also video images and audio data, of course, but the most of the cases, as all the other participants said, or panelists said, is basically really high frequent time series data. So we also have data pipelines in the applications, but unfortunately, the data does not always fit what you need for the machine learning part. So you have to do some transformation of the data, and using fast Fourier transforms and these things. So it's easy and difficult at the same time. Easy because we have the data, difficult, but because we have to figure out how to restructure the data so that they fit into our targets for the machine learning in the embedded space.
Great, thank you. We actually have a question from the audience already. Let's stay with you, Michael, since we're over at Siemens. How do you see the split between embedded ML versus cloud-based ML? How does that look for you?
For me at Siemens, it's really easy because, as said before, it's the embedded ML is more for data that should be basically, let's say, transformed and built into some result. When it is created locally, it should be done locally. So especially for if it's not high volume data, which needs to be stored in some data lake or something like that. But for the really big data, like videos, audio streams, and for the really large things, which have to be stored centrally because they need some extra processing, which cannot be done by embedded systems, of course, then we also have cloud-based solutions. The problem, obviously, is that not all customers want to spread their data around. So if you build something for an automotive vendor, they don't want that data is leaving the machines or the robots or something like that. So it's basically also some customer requirements that forces us to use embedded ML. But I think embedded ML is a really cool solution because it also reduces the network congestion. So there are a lot of reasons for using embedded ML. And I think most of the cases embedded ML makes more sense than storing and processing everything in the cloud.
Sure, yeah, sure. Juan, what do you think? How does the balance between embedded ML and cloud ML look for your industrial applications?
Yeah, I fully agree with Michael, but maybe if depending on the volume of data you need to process, of course, you may need to use one or another solution. But there can be also a difference, or depending on if the data collection is done in only one point, or has to be is distributed across different points, or taking different data in different points. For example, imagine you want to improve a factory line, so when you manufacture some product, the product is going from one station to another station where you are doing different things, and at the end of the line you do a quality test, and if the device is okay, it passed the test, and if not, you threw it away. I mean, you could apply measuring each one of these stations, doing intelligence, so that you may learn that a specific product, even in the beginning of the chain or even in the middle, you can detect that, okay, this product, based on what we have learned until here, this product is not going to pass the quality test, so better we throw it away here, and we give a place for another product. Of course, this has to be very intelligent, because has to be very tuned, because you have to discard products which will pass the quality. So this is, for example, something which you cannot do it in every station independently. So we need to look at the whole picture of this artificial intelligence. Maybe each step will be a machine learning step, but the whole picture is an artificial intelligence solution, which I don't see other option to run it in the cloud, because you have to look at that of a whole. But I think machine learning, embedded machine learning, doesn't mean that the artificial intelligence can run maybe in the cloud, and you can run learnings on the embedded systems. So I think there's also solutions where you can combine machine learning locally embedded, but the artificial intelligence as a whole can run on the cloud.
Yep. Menno, I'm going to ask you to chip in here. Menno, do you use a balance between cloud and embedded ML, or do things like privacy and security prevent you from using the cloud today, or how does it work from your viewpoint?
No, so the question about a split, I don't see a split. I see a sort of complementary of the two techniques to each other. And privacy, of course, and security is a huge issue. Yeah, and embedded ML does take away some of the risks. That is fantastic. But what we do a lot is to combine data from all kinds of different sources, and then a cloud solution is really the way to go, or maybe an edge. But then we have to solve the security issues. Yeah, privacy. Well, we make steel. Yeah, they doesn't really care about privacy all that much. So, and of course there is some data streams that you do want to be very careful about, but typically that's not our biggest worry. So, no, I see it as an extra step, not to replace cloud-based AI at all. Also, the training can be done very much in the cloud and then deployed again on the embedded ML. And so, as such, I would be struggling to do one without the other.
Okay, yeah, some great points there. Mittal, let's come to you next. Mittal, how do you see the split between edge or embedded ML and cloud ML? And what do you have issues with cloud? Like Menno was talking about security there, for example. What do you think?
Sure. So, I think that, I'll agree with what we discussed. I think that, there is instead of speed, I would say like more complementary. We have to build a purpose-fit, architecture here. And, embedded ML has its own space where, you're next to the, at the edge of the infrastructure. Whereas on the cloud side, you have a fleet information across, where you have a large volume of data. Definitely that, you don't want to pump everything. At the same time, the embedded level, when you're developing ML, it needs to be, performing a certain, limited processing capability. There are constraints on memory. So of course, you're in embedded ML, you are working in a constraints environments, legacy, processing capabilities. Whereas for cloud, you have different challenges on data privacy, as we talked about. So I would say there's a different challenges at different levels, and they are complementary. We need to design what makes sense, as Menno mentioned, like a high processing capability. That's what we leverage at the edge. We provide metadata to the cloud, and then cloud gives you the perspective of the fleet of your infrastructure. So it should. I don't think that there's a need for this versus that. I think it's more about what makes sense at what level, and there's space for both.
Yes. Okay. Let's talk now maybe just a little bit about the challenges of challenges of using ML in embedded deployments, particularly for the industrial application that we're talking about here. Who should we come to first? Let's come to Juan first. Juan, what are some of the biggest challenges around deploying embedded ML in the industrial environment today?
Well, there are several, I think, but
okay.
I will mention just a couple of them. I think one is an obviously lack of expertise and know-how in this topic. This is very new, so it's not easy today to hire people with background on machine learning and experience, and but this will be solved with the time. The other one is maybe related to the deployment. So, and how, at least in industry, I guess the other panelists will think in the same way. So in industry, you want to be really sure that what you are applying, the algorithm you are applying, or the artificial intelligence solution you are applying, it works. Because this is here you are inferring from data, so it's not a kind of deterministic solution which we used to work, in a behavior that follows a state machine. You have an input and you know exactly what will be the next status of your state machine. Here is something that is undeterministic, and you have to train. You have to try a lot. So I think you need really a defined process to go from a proof of concept, to when you develop your solution, a really defined steps to go before you do a rollout or a full deployment, to be sure that what you are deploying is the right solution, that you will get the benefits you are expecting, which you have been able to test on the proof of concept. So to avoid not only economic losses, but you can, depending on the industry, it can be really a tragedy, something really bad which can happen. So I think this maybe is the two challenges I see most important, at least from our side.
Yeah, they're the big ones. Menno, let's come to you next. Menno, what are the biggest challenges that you face using embedded ML?
Well, I think the new hardware that you need for us is new. So we are still coming to grips with it. And that is something that we learn about. And I agree, it's not that you put an academic paper and then the experts come pouring towards you. So you need to learn yourself. It's doable though. It's just work. It's study hard. The reliability is something I'm worried about in the sense that all the hardware needs to keep working. Yeah, the AI needs to work, but if the hardware fails, then and our environment in the steel industry is not always the most friendly for any hardware to keep working. So that is something that we are seriously worried about, and we try to mitigate. But I guess that would be the two challenges.
Yeah, I can imagine. Mittal, what do you think? What are the biggest challenges you're facing with embedded ML?
Sure. So for industrial, it's a different complete, I would say that's IoT we could talk about versus IIoT. When you apply this to industrial segments, that's a different application altogether. So, typically that's, the expectation or confidence of this output, it's not so okay that, okay, 90%, can I manage it with 90%? What about those 10% scenarios and the failure cases for that, right? So when we talk about accuracies and confidence, that the expectation is 100% there. So implications are on interruptions of processes. There are some of the implications could be on the safety and those are the protections of the equipment. So we need to be really understand that how does ML interconnect with what Juan mentioned, other logic-based systems, because that's you need more predetermining outputs. What goes in, we know exactly how output would be, but here it depends on data, how you trained, how you tested. So those are the some caveats, and also the kind of a life cycle management aspect that it's deployed. So it's not that in the cloud I can continuous improvement, and I have access of the devices once it's being deployed. Oops, now I have 90. I can increase accuracy from 95 to 99%. Can I upgrade those ML algorithms? Well, you don't have access of those edge devices once it's deployed, and you don't want to interrupt processes as well. So it's I can keep on going. It's completely different. I would say the applications when you talk about industrial segment.
Yeah, for sure. A lot of this, I guess, will be application specific. Industrial is a broad range of applications after all. Michael, let's come to you on this. The biggest challenges facing your rollout. Yeah,
I agree to most people here. Basically, the rollout, of course. What do you do if you want to update your model? And how do you roll out the software on the device? Will you do it by over-the-air transfer, or will you, which is feasible, but not always from a security privacy standpoint, or will you do it by an Ethernet, industrial Ethernet, for instance? So these are the small problems which are really affecting us. And the other problem, one of the other problems, is basically do you get the right experts, or how do you get people in your teams in order to be experts in this area? Because in most cases, not only at Siemens, but also at other companies where I've been, they are using architects and developers are becoming data analysts, which is not really the right way to go. And the third aspect from my viewpoint is also social aspect, because people think that AI is really smart in the sense of human intelligence, but this isn't the case. It's only probabilistic algorithms which give you some numbers, and which are also depend on the amount and quality of your data. So how do you get the data, and what is the right model to use? And there are not too many models for embedded ML, but most of the models are basically for computer vision and speech recognition. So this is also sometimes can be really difficult to achieve.
Yeah, great points. We have another question from the audience here. Audience member is asking, looking at ML in general, have the industrial experts seen anything around self-learning algorithms? This is mentioned many times, but have you actually seen self-learning algorithms working in real-life industrial contexts? Mittal, maybe let's come to you first this time. Have you seen self-learning out there in the field?
I would say in a controlled environment, yes. So not many in the field, in real life, yes, it's seen it. But when it comes to the it's of course it's deployed in a control environment, so it's not being supervised from the the process people, right? Now coming to self-learning, absolutely, like that, at the age where the applications where it's applied to the process, there are changes happening. The self-learning I wouldn't mean that that's complete. It has to rebuild the entire model, but I would say that it's more about self-tuning instead of self-learning. So absolutely, it has to tune over the period of time, because there is going to be implications on over the life cycle of that asset where it's applied to, or the measurements, sensors, the drifts, the accuracies of the measurement. So I would say that it's definitely something that needs to be considered.
Okay. Menno, let's come to you next. Have you seen self-learning algorithms out there in the wild, or are you using anything like that?
Well, I guess I'm not as advanced as GE is at this moment. We find self-learning, technically it's not that complex, but in practice we find it quite scary. So what we do typically is supervised learning. So we retrain and everything, but there is still a human accepting the solution or not accepting the solution. So real autonomous self-learning, as in, no idea what the model is doing, but I'm sure it's getting better and better. We're not that brave yet. So it's not that we couldn't, but to be honest, maybe it's for our industry, but our environments are not that volatile that it is a necessity, and so it's probably a risk-benefit type of trade-off. But it's also the people. A big part of my work is to make sure that people understand what they can expect from the model and what they can't. And if that changes all the time, then I need to manage that change as well. So it's change management rather than technical stuff. So for now, I am reasonably happy with my sort of supervised learning systems. In the future, I'm sure we will get more brave and think, well, this is under control and we can make it self-learn.
Yeah. Michael, anything to add on self-learning algorithms? Have you used self-learning algorithms in these kind of applications?
Me personally, not, but colleagues from me, basically the user experience guys are using self-learning, like reinforcement learning algorithms to really figure out what the normal usage of an application is. It's not in the field automation part, it's more in the user experience part. So how do people really use this application or that application in order to figure out what would be the best user experience? How can I improve on that? And that's basically more in general ML and not in embedded ML, of course, but that's something I've seen in the real life.
Oh, that's very interesting. Thanks. Juan, let's come to you next. Juan, do you have any experience with these self-learning algorithms? Have you seen anything interesting?
Well, I mean, not in our case. I mean, if we understand self-learning like really an algorithm that is completely changing the behavior based on the inputs from the data is collecting constantly. I don't see we applying this type of solutions because we don't need it. As similar to Memo said, I mean, manufacturing is an activity which is mass production. So we are doing the same one after another in a very defined way. So it's the factory lines does not change from day to night. So we have time to train algorithms. So, but for me also self-learning is like as Mittal was saying, is more about tuning your algorithm with always collecting data to validate and maybe you tune a little bit the algorithms. In this in this concept, yes, but on the other type of Terminator, artificial intelligence, self-learning algorithm, no.
Okay. Another question from the audience. Audience member is asking, are there tools or best practice mechanisms for a distributed data lake on devices such that data is only uploaded to cloud on demand and avoids duplicate transmission. Michael, have you heard of something like that?
So that's not really my expertise.
Okay.
I don't know. Really, I have not heard about something like that. Either it was stored in the cloud or directly processed in the devices, and then the combination of both. But I've not seen distributed data lakes across embedded devices, to be honest.
Mittal, have you seen a distributed data lake on device, or any idea about best practices for that?
Sure. Yeah, I can just throw light. If I could understand the questions, avoid duplication of transmissions. The kind of practices that I have seen in the industries that use the tagging of the data. So definitely like that. You have to tag the files or the information that you are traveling with the time or based on the date or whatever. It's very important that you appropriately categorize the data or so that you avoid any duplications. Typically there are communication protocols takes care of that duplications part. And when it comes to distributed data, like it's really, I wouldn't say that's the way we typically do, but there are on-premises implementations where it does collect the data and then send out in a batch. So there are different mechanisms. It depends on absolutely the need of or requirements of that particular project. So we do this based on the project requirements more often than kind of a standardized way of doing it.
Thank you, Juan. The audience question was about distributed data lake on devices. Yeah. Any ideas? No. Okay.
This is not something we do. I mean, if we want to process the data on the cloud, we do the transmission of the data, and then we do the processing there. And if it is embedded ML, we do the goal is that the small device to take decisions. Of course, we can send data informing about the decisions, but it's not we don't use a kind of distributed data stored in the devices and upload the data on demand.
Menno, anything to add here on best practices?
For us, that's new territory. We are experimenting a little bit with it, but I am nowhere near to be able to give an informed opinion on that. Sorry.
Okay, no problem at all. Let's go to a new topic then. Let's talk about how we can improve sustainability for industrial technology using embedded ML. Mittal, I know you have a take on this. How can we improve sustainability with embedded ML?
Sure. I think there are multiple aspects of sustainability as overall picture. I'll just talk about very couple of them, touch upon. Of course, that doing the predictive analytics and some of the we expand the life or sustainable making infrastructure sustainable so that in terms of overall uptime and the equipment life improves. Also the sustainability on the technology side as well, so that we could deploy this embedded ML analytics to the existing hardware, and although it's has a comparatively very low processing capability, but we make it embedded ML efficient to be able to deployable instead of starting from a new I would say devices or infrastructure requirements. So we try to avoid those things, as well as that energy efficiency. I made some of the applications really we train to deliver reduces the carbon emissions, so decarbonizations plans help with those kind of analytics itself delivers that sustainability model as in general, improving more renewables interconnections to the systems, and maximize the output of those resources. So just to give you very few areas on application as well as on the infrastructure side that we could make it sustainable.
Yeah, thank you. Menno, let's come to you next. Menno, are you using embedded ML to impact sustainability in your business, and how?
Well, in the steel industry, sustainability is the thing. Yeah, we are a mass producer of CO2, and we happen to produce some steel as well. So sustainability on anything that contributes to sustainability is by default very, very relevant. I've lost your video. Are you still there?
I can still hear you.
Okay. You're back on now again. Okay. Good. Embedded ML for now, it is more on uptime and what Mital was saying at the moment, but we see other ML, and that they will also become embedded ML application that really sort of save us energy, save us CO2 emissions, save us other dust emissions or what have you. So it's getting there, and it's one of the key reasons why we are so active in this field.
Yeah, very important. Juan, let's come to you next. Juan, how are you or your customers using embedded ML in their sustainability projects?
Yeah, one of the ways of using it is with the goal to save energy and reduce CO2 emissions. And the other one is to give our all machines a longer life, to make dumb machines. Or we are today, since the IoT started, we started to retrofit machines which were not connected and have no any type of intelligence or sensors on that. We have been connecting these machines, adding retrofit solutions in the IoT, industrial IoT solutions, and now we are, instead of sending data and do the analytics or the data on the cloud, we are the type of data these machines we are collecting from these machines are quite simple, because they are dumb machines which are doing simple tasks, but we need to know how much time the machine is operated, how much failures they have, do predictive maintenance, things like that. So being so simple data, relatively simple data, we can easily apply embedded machine learning locally, on these machines and take the decisions directly there. So yeah, saving energy and reusing our assets, or giving a longer life to our assets.
Yeah. Finally, Michael over at Siemens. Michael, any ideas on embedded ML and sustainability?
In addition to what Menno and Wow said, for instance, so I think also the problem that, for instance, if you have an industry automation, or some of the products we have are really long-standing or long-during products which cannot be changed in 10, 20 years. So if you build a power grid or something like that, that's really unlikely that it will be changed or rebuilt in 5 years from now. But if you have something like the embedded ML stuff, you can really add advanced services to it. You can use the data in ways which you haven't done before, like energy analytics and efficiency. So that's something which is really important. It's not only providing machine learning to existing hardware, but you could also add IoT devices to the existing infrastructure. So there are a lot of ways to make invest in such grids or infrastructures basically more sustainable by helping customers to really achieve goals and provide more advanced services to them.
Yep. Okay, I think that's all we have time for today. Thank you everyone for the really interesting discussion. Thank you very much to our panelists, Michael Stahl, Mital Kanabar, Juan Noguera, Menno van der Winden. Thank you very much to the audience as well. Thanks for the questions. I'm sorry if we didn't manage to address all your questions today. Thanks very much everyone for watching, and enjoy the rest of the conference.
Thank you. Bye.
Thank you. Bye.
Bye-bye.